Hello, welcome to BLENDERSUSHI channel. I'll be doing another live noding using animation nodes and Sverchok. I'll be covering more about matrix and vector. It's actually kind of like a continuation from previous live noding where I'm kind of stuck near the end where I try to make like these global transformations and I kind of stumble and I think I made a little bit error near the end. So I'll try to cover that area once more. Yeah, let's just do it. So let's go to compositing layout. I'll be focusing more on animation nodes today. I'll be covering maybe I'll use Sverchok near the end where I try to make like variations in instances. But for now, I'll try to recreate the mandala setup. So yeah, let's do it. Basically, the main point of previous live noding is we can use vector plug into the matrix to create like instance copy. Um, let's do it again. Create a new node tree, and so we have just let's hide this lamp and the camera. So we have this cube, and so as we know, we can use the object matrix output instead of the object transform output. We are using the matrix in previous live noding, and with the matrix we of course can bring in vector. See if we compose the matrix. So if you're using just object transform output, as we know, we can select the object and then of course control the objects in 3D scenes, rotate and whatnot. But we're gonna do it with a matrix because with matrix we have kind of a little bit more flexibility sometimes. Sometimes you just need object transform output, but we're gonna use the matrix here, so delete that. With the object selected, I'll grab it and we're gonna use the matrix. And then if we use things like random vector, we could actually have instances, but in order to do that, of course, we need object instancer first. When object instancer at the beginning, you definitely will use a loop to kind of modify the copy. So I kind of moving backward. This is how I usually started with almost lots of animation nodes set up. I start with a single object and then I tried, okay, that's what the matrix does. So we can translate, okay, translate, rotate, and scale. But as we know in the previous live noding, if we provide multiple array of vector or array of rotation or scale, we can kind of have like a variations in the instance. But so far we're only talking about the variation in transform. Later on, I might talk about how we can make a variations within the mesh itself. A little bit more complicated, but it's really fun once you understand. So with the cube, I'll select our cube right here. Maybe I'll get rid of this guy. With the object selected and free, I'll grab it. It's the original cube. I'll make maybe 10 instance, and I will loop it. Okay, I'll tap W, and gonna loop through the object like that. So just copies, 10 copies of the original object, and we plug it into the loop. And with the loop, we just, okay, for each and every object, yeah, we just gonna randomize the position. So we're gonna plug in the index into the seed and the vector into that. So we have seen this I do this multiple times by now, but just to be really clear, so this is the original object. That's what we got. You can of course make variations in the scale. Nothing new here. We're gonna save it as animation node Sverchok matrix 2. Animatrix 2. Save the blend file. Okay, so if you have multiple vector, which in this case, because we have 10 objects, we can do that quite easily, right? You can also use things like say if you have line mesh right here, and then we can use the, let's say, the vertices. Oh, by the way, with the line right here, as you know, with this guy selected, you can go to the secret menu here, advanced node setup, hide relationship lines. Apparently there is a shortcut for that. It's a U. If you tap U, then we have this menu. That's the secret menu, and you just hide the relationship lines like that. Alright, so let's say instead of random vector, we want to put the objects in line. Let's do that real quick. You might think of putting the objects inside. In this case, we want it to be outside of the loop. You put one day, you actually maybe later, a bit later, I will have like another demo where I create duplicates of line mesh and then make variations inside of the loop. But in this case, we don't need to loop the line, we just need to loop the vertices. So let's create a new iterator, vector list, plug that in, plug in the vector there. Okay, so that's 10, 1, 2, 3, 4, 5, 6, 7, 10. We have 10 different objects. Where is our original cube? Okay, yeah, it's that. Normally I hide it into, put it on different layer. So we got that happening. We can put it to the side. I use line often just to do this real quick. 10 step. Yep, something like that. Sometimes you might be wondering what's inside of that data, so it's good idea to always check using the debug loop. So debug loop. So we have the object and the vector as the list being iterated inside the loop, right? So we can have a look at the object and then check it out. So how many objects? I turn on the line numbering, and then yeah, just turn it on. So that's the name of the instance. We have 10 different objects, and then you want to see the position, you can do that as well. Just plug it in, and now you have the objects and then the positions separated by space, so you can tell really you can see real quick. Okay, so that's what's happening. Maybe so if we have like 14 different positions, 15 different positions, so that's too much, or we have less. You see, if we have less, some instances actually have the same position. I think you might be able to repeat that. For just for now, we always make sure the object copy is the same, has the same number of the array, total array, if you're doing the loop stuff. So yeah, that's the basic idea I want to so that you're very clear. If you have a bunch of vector and then you have some object copies, you can use the matrix to kind of make duplications, kind of. And then so yesterday, actually, in previous live noding, I make kind of like a mandala setup where we have bunch of objects all in the circle like that, and then I try to make it so that the object goes like that, kind of that structure like a flower, and that's and also I want to have like a global controller. I'll do it again real quick, and I'll do it kind of backward. This time more detail and just focus on animation nodes. You can do the same using Sverchok, and yeah, don't worry about that for now. Let's save this. I'll just create a new blend, save it as NSV Animatrix part 3. Compositing. Let's hide this into layer 2. We have the default cube. New node 3. So I'll do it backwards. Okay. Object matrix output. Grab our object, and with the matrix, we're gonna create the matrix list. Create matrix list, and there's another one. Combine matrix list and combine matrices. Be very careful with this. So there's a combine matrix list and combine matrices. The one we'll be using today is combine matrices. I haven't used combine matrix list nodes before. There must be like a super useful must be like use for this node, but for now that's actually the one we need. And be careful. Let's say you are okay, let's do it slowly. We have our objects, and then if we want to move our objects, we use translation matrix. Okay, we can move it. So this is kind of a separate nodes to do translations, and there is also rotation matrix, as we know. The angle is in radian, be careful. So with that, you know, you can do the XYZ rotation. Okay, And in order to combine multiple matrix, we need to create matrix list. So we create a list of matrix first. So plug that in. For now, I'll just have that guy. If I try to plug this in directly, I will get a get list element. That's not what we want, okay? So, and what I'm going to do is actually translate the objects to the side. You've seen this this few times, and then I will rotate it. I will rotate the object, right? But it's not happening because that's get list element is just get either one of this list of matrix. Yeah, that's not what you want. You want the combined matrices. We will use this later. So let's plug that in, and then the result into the matrix for matrix transformation for this object. So let's say we translate it 5, and then with angle, it's in radians, so you can see it goes really quick from 0 to around 6.4 or 6.2. Yeah, that's 6.28. Probably it's 2 pi. Yep, that's actually what we want. We want it in radian, so radian, degree to radian, plug that in. Degree goes from 0 to 360 for one full rotation. So this is the basis of our mandala setup. We can actually have the scaling. I believe scaling can be useful later. Scale matrix. Yes, scale. Actually, maybe not in this part. I might need to scale the objects before rotating. Rotate and scale are not friend, I guess. So I'm gonna change the order. Scale. I might even need to scale it before the translate. Let's do that. Scale. Yeah, this is better. That's actually much better. Let's put it back to 1. So this is gonna be a cool mandala setup. We're gonna scale. So we have this scale, we have the translation, and then the rotations. And in order to create the mandala thing, we will need to create a duplicate objects. Let's save this real quick, and we're gonna loop this guy. So it seems complex, but if you follow all my live noding up to now, it's actually rather simple. It's complex for if you show this to people who never seen animation nodes, but this is still the basic intermediate, I guess. So we're gonna loop. So we're gonna use object instancer. Let's grab that object. That's our kind of master copy. And for simplicity, we're gonna have just 10 of the cube. Right away, we can see the 10 different copies all sitting in the center. And we know we're gonna loop through the objects. Okay. So everything is good. What's next? We have the translation, we have matrices. Okay, we know that the object should go there. And now, if I try I just plug in, we know that from the whenever we have loop happening, we have 10 objects and we have the index. The index is always like kind of like a list that start from 0 up to the total number of the list minus 1, so 0 to 9, and it's actually 10, of course, 10 different copies, right? So you could let's say if I just plug in the index into degree. So okay, that's cute. What do we do next? That's usually how I test the setup, like this. Ah, so it does that. That's kind of what I want. That's starting to look like the mandala thing. That's, let's see, okay, number 36. Oh, 36. 36 because for one full rotations, and we have 10 objects. Each object will need to be rotated by 36 degrees. So all right, so that's kind of working. So that's good. And then okay, let's arrange this real quick. And then you might wonder, okay, so we have that. Okay, the translation does that. Nice. That's useful. And then let's say you're changing, you test it. Okay, I'll change the number of copy, make it to 5. Oh wait, it doesn't change the, it doesn't create the circle anymore. So we want that to be automatic. So how are we going to do that? The iteration, actually, if you look at the iteration, the iterations is 10, 10, 10, 10, 10, 10. So for 10 objects, the iteration is kind of like the total. We can use that because we know to make a full rotation is 360, and then we have iteration 10, 10, 10, 10. We can definitely use that to get 36. So the total number is here, so we need like a 360 divided by the total number. It's gonna be, it's gonna be 36, 36, 36. So we can plug that in. Hide that. Save it. 360 divided by B. Math multiply. Let's delete that. Now if we have, again, no matter how many, let's say, okay, we have 3, 4, 5, 6, 7, 8, and it's automatically create this circular kind of construction. Nice. So it's working like we want it. Let's see if I forgot something. We want to hide the line, so I'll select object instancer, tap on U, hide relationship lines. Okay, what's next? This is where I was stuck the other day. I want to make a global controller, and I did it way using another iteration. Then it was totally wrong. All you need to do is actually just, if I create a compose matrix and plug this in underneath of the create matrix list, now we actually have the global controller. I think it's a really good habit to have this. If we are using we construct all this kind of complex setup, we always want to be able to move the whole thing somewhere else. Very important. So that's good, that's working. And then we have the scale. The scale, of course, will work as well. Can be useful. Can leave it there. Oops. Put it to 1. So what I did yesterday was to create a group. In this case, the mandala can take advantage of group looping. So let's do that. Subprogram group. All right. The group is gonna be the, let's call it mandala. This, let's quickly give it different color. Can I use you? No, I cannot. Let's use the menu. Choose a color that's kind of different. Okay, pink. Hide it. With group node, be careful. So you don't want to, you cannot, unfortunately, you cannot just plug in the source of object instancer into, that's gonna give you error. What you need to do is, you see this loop, object instancer, and plug into this guy, which is all this loop happening. The group input will be here. So let's just do it. So object list, this is going to be our instance object, and let's use the group. Now the actual group is actually this guy, so that guy right there. Object list, plug that in. So this is the beginning of our group input. Takes a while to understand this actually. Next, if you try to plug in this guy directly to the group, it's gonna give error. That's wrong. Also, you want to plug, I'll start with the scale. Plug the scale into the parameter. Translation. And the angle, we don't need to do anything. But here, the compose matrix also need to be outside. It's better that way. This goes in there. So now it's gonna be the global transform. Global transform. It's gonna be like that, right? It's gonna give our user the control over the whole thing. But since we are using group to keep everything together, we're gonna plug this into this guy. Scale. There's already translation now. Scale. Translation. Global transform. And this guy go in there. Yes, that will work. Let's save this. And let's see if we have anything else. Nope, that's pretty much it. Now, if you have, let's say you want to create another object like icosphere, and then we create another mandala. setup, and then we have this to there. Object list, this is gonna be the icosphere. It's gonna be there. You can now have a new one, and this will work. Pretty cool. Oops, the X, yes, so that's cool. Okay, you might also want to be able to rotate this mandala thingy, so we can still do that. It's not too late. With a kind of like a node workflow, node-based workflow, we can always go back. A and B, convert angle to radian, degree goes in, so we can have like an offset for the rotation. Number math. With offset, usually use add or subtract offset. That's offsetting the thing. So I can plug this into that guy. It's gonna be rotation and rotations. We're gonna plug into the group. Now, you see what's happening when you plug that into the group? We actually kind of factorizing the whole loop. It's a complex terminology. I know it's gonna. If we have group set up, we can easily make lots of variations of this loop right here. Let's arrange this real quick. This is our L G L G. That's the cube. That's the icosphere. We can have as many as we want. We can rotate it as we like, backward or counterclockwise or clockwise. We can do that later. Okay, that's the mandala thing. Easy, super easy. And let's see, so you can use like a frame, for example, rotating. Let's deal with this icosphere now, and then playback. You might see that my computer is struggling at the moment. It's like 8 frames per second. The funny thing is, if I make this into full screen, it's actually a lot faster. It's become real time again. So I figured this node editor is using a lot of memories to display all this. I'm gonna save this now, and in order to see it in real time, all you need to do is just to make this full screen. That's cool, right? I believe you can also use the option here instead of always, maybe only updates when the frame is changing. So no, it's okay. Leave it like that for now. So what's next? Let's stop our mandala from rotating for now. Rotation 0, global transform. Check it out. Okay, global transform is working. Rotation, good. Scale, nice. Everything is good. Let's reset the number. So if you just give this to another Blender artist, they can simply use it. Now we're gonna do something interesting. So we have this object, it goes into our group thing. It doesn't have objects out. That's actually, we haven't made it, and we can do that as well. Output node can return an object, so put it right there. I will do it the wrong way. That's wrong. It's gonna give you error. Once again, be careful with that. So this is your loop, all the crazy stuff. What you want is plug it into this guy. Select our loop node, invoke subprogram, and then tap U, and wrong, I should have select loop input, tap U. Now just tap the new generator, or use object as output. Use object as output. Use object as output. Let's do that. So we have object list. Actually, maybe don't do that. Normally I actually click on new generator output and then type object list. This, put it there, output the object. Now here with the loop we have object list, and just plug it into that guy. So now we have another slot output there, and believe it or not, we can now loop over this group, loop through object list, group of this mandala thing, and what else can we do now? We can iterate over each object and do something more using matrix. So it's matrix inside matrix. This is just like Inception. It's crazy. Object, we can use object matrix in. So for each objects right there, we're gonna do something. Okay, it's getting crazy, but we'll continue. Matrix output. Are we going to? Yes. Output the matrix. We're gonna decompose the matrix. Now we have translation, rotation, scale, and here gonna grab the object again, goes back to center, which is pretty bad. It's kind of back to origin. We will use the translation here, vector math, but I'll do a quick trick. I made a mistake in previous live noding, but I think this will work. I was using subtract when I using add is actually will work. I don't know another way to do this. Maybe there is a better way, but this is what I like to do now. So matrix, compose matrix, decompose and compose. Matrix in, normalize. There's another vector add, plug in the translation, plug that in into the matrix. Okay, back to where we were. Now we have this control. Now if we, let's say instead of icosphere, if we use torus, let's grab the torus. We have ring. I haven't tried Suzanne, but with Suzanne, of course, we can, with the monkey head, we have kind of like a, we know where Suzanne is facing. That can be important. Let's grab Suzanne. See, the monkey is facing like that. We might wanna maybe rotate the monkey in a certain way. Probably we can use the translation directly into rotation. And then where's Suzanne? Suzanne is pointing at the minus x. So no, minus y. And the top is gonna be the z. Okay. That might be what you want. Although, yeah, I don't worry too much about that, but I just want to show you. It's all kind of coming together. This is, I guess it's kind of more intermediate matrix and then vector, using the matrix to make this arrangement. And now we have, okay, we have that as well. Instead of, now we know Suzanne is facing the right way, and then I'll just use torus for now. It's faster for my computer. Okay, the ring, you can rotate the ring, etc. But I just want to show you we can kind of play around with this vector math, normalize, scale. Whoa. Somewhat complex, but it's interesting anyway. Translation goes in there. What am I trying to do? Scale, sine wave. If we use frame and math, see what we got. Frame, math, sine, plug that in there. we might be able to use time delay, perhaps. Let's move that. It's kind of, the mandala is kind of breathing. We can use frame time delay time. Plug the time here, and the time goes in, the output goes in there. But we're gonna use maybe the index, so we have kind of like the offset. Now we have this guy happening, which is cool. And now we can, let's see, use another math and plug it into the delay. We can increase it like that. At this stage, you know, we are keep adding details, and it's really up to you how much you want to add, what kind of details, and you kind of playing around with, okay, what if we do that? Okay, apparently it's giving that. Maybe maybe we kind of have control over the time as well. Slower, faster. It's up to you, and then all this value you can play around with. And maybe, hey, what if we have more of this ring instead of 40, 20, 60? Okay, 60 give you that. It's very interesting. You see, how in the world you ever think, how can we create like that? It's kind of like accident. It's I don't know, there must be like a mathematics formula that creates this automatically. But the fact that you get that kind of pattern by mistake is kind of amazing. If I make this full screen, see, it's playing in full speed. Note, I think the note is making things slow. I don't know, the note grow. Maybe there's a way to stop making it lagging like this. What else can we add? Normalize, maybe the scale. Perhaps we can also you can do a lot with the sign here. You can offset it and multiply the amplitudes and stuff. Sign goes into the scale. I might have done something different when I try this myself. I kind of like this add. What if we add? So add give you that, which is nice. Time delay. Maybe you can also multiply it here. Multiply. Is that multiplying the amplitude? No, it's multiplying the time. No, that's silly. Sine. Perhaps we can add a multiplier here. Okay, that's multiplying the amplitude. It's nice. And you know, we have the scale control here as well. Now we're getting into weird realm of Mandala. You can rotate each and every single one. Anyway, that's the whole mandala business. I don't know how I get here, but basically you start from simple matrix transformation for single objects, and then once you add like an array of copy of objects, and then you keep thinking about what can you do with the matrix, you can end up with something like this, which is really interesting. I found it interesting. Maybe you find it interesting as well. It might be complicated, but that's pretty. Once you get here, you kind of don't worry about what else. You don't worry too much about what's happening inside. You just know, okay, what if we add this, and keep adding details until you get what you want. So that's with the mandala. Did I miss anything? You can of course colorize the mandala, but I'm not gonna do that. I can show you the next thing, which is the line. I'm probably gonna delete something before I continue. I'm gonna keep the mandala. Maybe we can use it near the end. The mandala is this torus. I'll just make it 3. So it's just 3 ring. 3 doesn't look good with me. 10. 10 is doing that. We don't need this. Okay. Translation, make it small. Says then it is C. Select that. Delete. So we have this guy. Oh, I want to just hide them for now. So that's our mandala, and that's the original. I will hide them into a different layer. Now I will do something else. Let's play around with line. Line mesh node. What I'm trying to do is to create, as we know, this line mesh will create a line, and by default it has 2 points like that, and by increasing the step you will have more points. What I'm trying to do is using the matrix duplications, and I'm gonna create duplications of the lines, but I will also have like variations of the line. So let's do that real quick. How are we going to do that? You will see. We start with a object instancer, and give it a 10 duplicates. For this, I believe we just gonna have the mesh like that, and we're gonna loop this guy together. So object instancer, I will create a loop through object for each and every of this object container. We're gonna put a different data block mesh. Yeah, let's arrange this guy. First, we're gonna use matrix output, object matrix output. The object will be our object, I believe. That's correct. And the matrix will be our compose matrix for now. We're gonna make that kind of arrangement so we can have another. I'll duplicate the line mesh, because with the line mesh we have kind of 2 points and then kind of whatever divisions in between the 2 points, we can use that. I almost make a mistake. This guy need to be outside, I believe so. New iterator, not new iterator, it's gonna be new parameter, vector list. I put it in the parameter so that when I plug this in, it's not get iterated, it's just it list goes in and then it still lists inside, and we can plug that in. Index. Say okay, we need 10 step going up. Should we leave it like that? I guess that should be fine. This goes up. See, with our line mesh, let's create a mesh output. Mesh object output. Let's try this real quick. Create a new target. Mesh data, vertex to mesh, it doesn't work. It automatically creates that. Nice. Edges. We want this guy to go to the side. Let's do that in X. So we have our line. It's a 2 steps line. And with this guy. See, the thing that kind of a little bit confusing is whether we put it inside the loop or outside the loop. In this case, we want to put it inside the loop. So the line will go inside the loop. And somewhat we're gonna have some magic happening. Let's try. That's mesh data, matrix index. Okay. Let's hope this actually works. I might made a mistake. Vector list goes in. Maybe actually this guy should be iterator instead of parameter, so I'll get rid of that. Create new iterator. It's gonna be vector list. Plug that in. We're just gonna use the vector. We're not creating lines with this guy. We just use the vector to place our duplications instance. Okay. So back to where we were. So we have this and we have this. First of all, I will make a variations on the line length. If we, let's see what's happening if we plug the objects into the target. Okay, so now we have 10 lines, and each of every lines is the same in length, like that. And then you probably wonder what if I want to have a different length? Now this is the magic, yeah. This is the magic. Let's save this real quick. We will create a vector input. not vector input, probably combine vector. Here you see at this moment it's like this number and 0 0. We're gonna make a variations on the lengths by using float range, yes, and it's gonna be a 10. It's a list of float range. The amount is 10. Let's plug this in there. And then okay, so it's working. That's probably the old target. There's one that's actually 0 in length, so I want to start from 1 and stepping up. So 10 different lines. We make a variation of line. Very cool. Each lines have just 2 points. You could actually do also, perhaps you're using like a random vector. Random vector is always handy because whatever index you plug it into the seed, it will iterate and then it will generate random vector. So you will get that. You can scale it. That's like super cool. At this currently we have the lines being separated like that, but if we zero it out and then increase the step, well, wait a minute, 10. That's not how you do it. You need to, because we have the object instancer and we have this, we gonna increase. Okay, this is maybe, okay, that's funny. Okay, let's use integer input, maybe 10, plug in there, plug in here, there, plug in here, there. You have something like that, kind of array of lines. I found this super interesting, and you can, whoa, what's going on? Oh, okay, that's our mandala. Very carefully put this down there. If we play with the seed and just offset the seed, so we have kind of random array like that. Can adjust the scale. Yeah, this might be handy at some point. So we create something like this. We might have created something like this in the past using spline. This is just another way to do it. However, different setup, you might have a different kind of flexibility. The start also can be, we can have variations on the start there. Now what I will do next is, let's see, let's have just 10 lines. 10 is a good number. 10 lines. At this moment the line is all only have 2 points. Since the line mesh is generated inside a loop, you can make variations. So this is a kind of good concept to understand. So if the object being generated inside the loop, you can make a variations of it. I think with Sverchok you do this kind of almost immediately. Let's see, should I switch to Sverchok real quick? Maybe I should. Crazy Sverchok. Sverchok line is a bit weird. Here you can make variations. It's kind of needs an update, I think. But the circle will create. You can create variation using circle node. What I mean, so if we create like a viewer draw, this will generate just a normal circle with a radius of whatever radius. I worry about the vertices for now. So I like the circle in Sverchok. We need that in animation nodes, really. So here you will see something really surprisingly magical. Random vector. Okay, random vector. This is Sverchok. So what's with the matrix? Matrix in and out. Matrix in. This is the magic of Sverchok. Okay. Plug that in. Plug that in. How many? Okay, seed. And we don't have scale value here, unlike animation nodes. So I will quickly use vector math and multiply scalar and then float. To be honest, I'm not familiar with everything. Actually, I don't know everything about Sverchok or animation nodes. I don't know everything, but I'm learning every day, each and every day. The more I dig in, the more I understand a lot of stuff. Here you see with Sverchok, how many nodes do you need to create this kind of thing? Animation nodes, you need object instancer and bunch of stuff. But the main idea is very similar. Maybe Sverchok has kind of special way to do this. So, like I said, Sverchok line is a bit weird. I cannot actually make variations on the number of vertices, so I'll use just a circle. Animation node doesn't have circle yet, maybe in the future. Anyhow, so it's a bunch of circle. And if I want to make variations on the number of vertices, what do? I will create a range. I believe it's a range float range integer. It's integer number of vertices. We have start, step, stop, start. Let's say 3 minimum, stepping 1, stop at 10, 3 to 10, and plug in into that guy. So you have variations like that. I like how you in Sverchok, if we with a viewer draw is really interesting feature of Sverchok. If I get rid of the mesh data input, we get this matrix, and that's really useful. We could say random vector as the rotation. The rotation is slightly different to animation nodes. We have rotation and angle. It's kind of two separate things. Why? I don't know. It's probably Euler or is it quaternion? I don't know yet. But that's how you rotate in Sverchok. Goes in. Whoops. Sorry, angle. Put vertices back in. Poly, we can poly. So it becomes a circle. It becomes a polygon instead of just edges. Sverchok is cool that way. Save this. Let's just hide this back to animation nodes. So we want to create variations just like in Sverchok. We have loop happening. So we have, oops, I accidentally pressed something. Bunch of lines. Wonder if I can extrude this line. Mesh tool. Remove double limit. Recalculate normal. Mesh data operation. Edges to planes. Edges to planes. Vertices edges width. Vertices edges width. We're gonna do that near the end. Edges to planes. That's useful. Let me think. Okay, brain a little bit tired, but let's see. Float. Step. Minus random vector. Let's don't use this for now. Let's use this guy. Plug this into the end. So let's have this back. Okay. I can randomize this guy or make a sine wave or whatever. Okay, the steps. Yeah, let's delete the random vector for now. Steps. Let's suppose we create random integer, no, range integer range. Says list amount 5. How many? 5. Start. Let's start from 2. Step 1 amount 5. Let's do that real quick. Step. Okay. It doesn't complain. We just need to index amount. Maybe 10. Step 1. Start. Let's have a look at our lines. So it seems to be doing something. 1, 2, 3, 4, 5. Okay, it's working, I think. How many lines do we have? 10. Just 10, 10, 10 for now. Let's save this real quick. Whenever in doubt, we can always use the debug loop. Debug loop. So let's have a look. We have our object. That's the name of objects. Nice. That's the name of the instance copy, the name of each line. And then we want to see the length of each lines. So that's the length of each line. And then we also have the step. 3, 4, 5, 6. The very bottom one have 3. And then 6, 7, 8, up to the last one have 12 different vertices. So it's actually working just like I wanted. Just what I want. Let's get rid of the debug loop. Let's hide it. Three D view. So we have our lines. Of course, we can get rid of that weird lines there. U, hide relationship lines. Okay. What should I do next? Maybe here's the thing, when you're inside a loop and then you have this generator and then you wanna, okay, I want to kind of randomize the line inside it for each and every lines. Apparently you can. You not sure whether you do it at the very end, but apparently say this is a line mesh and it's generating all these vertices. If I want, let's say if we want to randomize the vertices, we can actually make a loop inside a loop. So with the line mesh selected, I will just tap W, loop through the vertices. Okay, that's gonna blow your mind. Line mesh. This gonna output another vector list like that, like that. Vector list will go in there. So that's inside the line mesh. So we can randomize random vector, or maybe random. We can use random Euler or vector wiggle. Let's do wiggle. Love the wiggle. Index, seed, evolution, frame. Amplitude 5. Vector goes back. No, we're gonna use a vector math. It's gonna add this. There. Time goes into the wiggle. L, 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 okay. L will select all the link nodes. We get something like that, which is also quite interesting. Let's quickly get rid of the grid. Don't need to see the grid. Super interesting. Let's lower down the amplitude. 0.2, 0.3. So yeah, so each and every line is actually kind of the same, it's doing the same thing. This is why I was thinking maybe we should do it outside, but then again, don't worry about that for now. We have the line wiggling. Full screen, line wiggling slowly. Increase the speed, 10. So line wiggling. So you have loop inside a loop. It's doing something to the lines. And if we cut that part, and if you use like a random vector, or wiggle, let's do wiggle, random wiggle, Euler wiggle, vector wiggle. Plug it to the end. Index to the seed. Zero out that guy. So we have something like that. We might need to be able to randomize further, but I guess this is very complicated already. Should be good enough for now, I guess. Yeah. Let's see, what else did I forget to show you? Should I put this into the mandala? Maybe we can, maybe we cannot. Okay, edges to plane. Vertices goes in there. Edges goes in there. Calculate iterations, vertices, polygon, width, calculate iterations. Okay, calculate iterations. Kind of like thunder, but not really. It's more like a ribbon. It's kind of just a weird looking ribbon. I suppose we can just end it there for today. So bunch of things to create this random looking mesh. In comparison with the Sverchok, I guess Sverchok has certain way in dealing with a mesh, of course. With animation nodes, you're kind of able to do that as well, which is slightly more complex, but it's actually kind of similar. When things is inside a loop, you can use the things like integer range or all others kind of list. Let's see, object in integer, get element, get random element, search element. You can even randomize the list with shuffle, slash, shift. Here there's this list fill and list repeat. That might be interesting to explore. And there's this truck, which is slightly more complicated. For now, alright. I guess that's pretty much it. Let's see. Get back to Sverchok. Let's hide this. Try to do one more thing. Okay, don't worry about edges to plane. I'm just gonna use the edge and scale, translation, matrix. Let's see if instead of the line mesh we use grid. Let's say we use grid mesh, and it's 5 and 5. Let's cut this, save this. Math. Okay, integer. So 4 by 4 is 16. We use math. Plug that in. Math. 16 object. 4 by 4. 16 instances. This goes there. Center. Don't worry about center. Distance. The line can goes up, away, instead of wiggle. Line just goes up in the z-axis. So I'm simplifying things a little bit now. Integer steps. 10. 16. Start 3, step 1. So that's kind of quite interesting. Still wiggling. They looks like they're doing the same thing. Let's see. X. Yeah, so there, I just want to show you that. And since we have the grid here, we have 10 by 4, 40 different line. But as you can see, this guy also need to be, you need to care about the number inside it. It's not automatic. Index step. But of course, you can kind of use a random value. At this moment, it gets pretty slow, so we'll go back to maybe 4 by 4, 4 by 3, 12 different lines. Index goes to index integer range. Might be able to just randomize this guy. Let's see. Random. Say random vector. No, random number. Between 0 and 1, make random number. So index goes to the seed. It's gonna generate random number, and then map range. Plug that into the value input between 0 and 1, map it to between integer range 40. Let's see. It's a random number, integer range, amount 40, start 24, step 1. This might not be good. Still working somehow. Yeah, I guess we need to probably take a break right now and continue in the next live noding stuff. Eventually we can create something that looks like what do you call it, lightning or electricity. Yeah, so that's kind of useful, but maybe one more thing is with the matrix, because this is animation nodes and so far we haven't been animating, so I think I will just gonna show you something interesting. Matrix output, object matrix output. So with this guy, and then we have matrix, create matrix list. Cool. And then we have like a compose matrix, one. So this will go there, and then we have the matrix mix, combine, matrices. So we have, say we put that object there, and then rotate it randomly. Here we have the second one, plug in there, put it there. This guy, oops, let's make another one. Random rotation. Okay, maybe scale it. So 3 different matrices. Now instead of combine matrices, you can mix the matrix. Mix is probably what you want to use to animate. Mix interpolations. Mix matrix lists. So mix is for animation. I think you can use it for animation. So with 3 different position like that, you can animate objects from 0 to 1 to 2, I believe 2. Or am I wrong again? So what's the, it goes from 0 to 1. 0.5 is kind of in between. So 0.5 is probably this guy. So I'll make it smaller. So between 0 and 1. You can make it repeating. Let's see if I use frame. Vector. Repeat. It's not repeating though. Frame. Okay. Frame goes from 0 to, it's too fast now, so I'll create math. There. 0.1. Now it's animating. Three different position, right? And it's animating and it's automatic. It's only the transform, but transform, you start with transform and then you will move to other area like maybe bones or stuff. At the moment, I think we have mix. Say mix. Quaternion, vector, float list, color list. Color list. You can animate color, matrix list, Euler, vector, floats, all these components of objects. Can we mix attributes? Maybe not yet. But that's how you can create kind of like a procedural animations using matrix, like this 3 different matrix. If you actually use a loop, and I'm not gonna do that now, it's just too crazy for one night. This, if you create a loop and then you have multiple array of matrix here, array of matrix here, you will end up with a kind of interesting objects, like a bunch of objects, all of them doing crazy stuff. Let's see. Actually, let's just do that. Matrix animation. So there's a single object doing something crazy. So let's say you're gonna loop it. Loop. Create object instancer. Let's say we have 10 object. Grab that guy. Plug that in object list. Get the loop subprogram. Plug that in. 10 different objects. What are we gonna do with 10 different objects? Say object. Plug into the object. Random vector for 1, 2, 3. Plug in the seed, random seed. Plug the index into the seed, different number. Plug this into the vector. Plug this into that vector. Plug that into that vector. Increase the scale. Increase that scale. Scale normal. So this is the master, of course. Master cube. Bunch of object doing crazy stuff right there. Different scale. Bunch of objects doing, each one of them doing crazy thing. Let's see, math. We can even delay the time. Wait, before we do that, random Euler. Seed and that seed goes into rotation, goes into the rotation, get into that rotation. So it's the kind of, we make like a dancing object doing dancing, and each one of them kind of doing the same thing at the same time. It's kind of interesting anyhow, and then you can probably delay time. Index goes in there, and then use math, multiply the time, randomize the time. So all sort of crazy thing. See, this is the full speed. You, the one that's just doing nothing, is the master. You are the master. Look at your clones. They are all doing crazy stuff. Let's slow down the time. 0.01. Oops. We have like simulation. In fact, you can randomize the Euler for its even the position. Okay, they are all repeating. Maybe we can do a ping pong. No, we can do a ping pong here. They're all doing the same thing, but imagine if you're kind of looping the thingy. So this guy goes into there, what's gonna happen is, let's watch this guy. So it's moving. We create something that looks like a creature, kind of simulations, but they are all procedural. It looks like something that moves inside the water or something. Yeah, but they're all, this is just a simple example. Just by mixing matrix. So mixing is for animation. So up to now we haven't really touched about animation, but this is one way you can approach animation using the matrix and mix matrix nodes. Okay, all right, thank you for tuning in to today live noding. I'll see you next time. Hopefully you find this video useful. Enjoy and see you